of f of x, and let's say it's equal to a number L. So what does this mean? This means, so I'll just tell you what it means and I'll write it down. It means that as x approaches infinity, f of x approaches L. So you might be wondering, what does it mean for x to approach infinity? It just means it gets big. So as x gets really, really big, yeah?
Would it be like an asymptote?
This is going to be a horizontal asymptote. Yeah, deep. Yeah, good. So this, yes. So if this happens, wow. Oh yeah. So if this happens, basically it'll look something like that. Yeah. So means that as x, so you could say gets big, gets really big, gets really, 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 really big. But the right way to say it is grows without bound. As x grows without bound. In other words, it gets big, f of x approaches L. In this case, it's like what Ethan said, we have a horizontal asymptote. So I should write that down. In this case, y equals L is a, this is the definition of a horizontal asymptote, is a horizontal asymptote. Asymptote is a funny word to spell. It has a P in it. It's asymptote. Let me draw the picture that I was drawing over there. So basically, like this would be L, and then so you have a horizontal asymptote. So when x gets really, really, really big, your function gets infinitely close to L. So that's the idea. So whenever you see this symbol here, it just means x gets really, really big. Hey! Luke, right?
Yes.
Yes. Oh, good. See, there is a, well, nothing. Good. Yes. Yeah, I called you Lucas earlier, but yeah. Yeah. There was someone else, Luke, and I called him Lucas. I'm like, we have a Lucas in here. No, it's not Lucas, it's Luke. So I was thinking about you, kind of, so that's good. You can do the same thing. You can have limit x approaches negative infinity. You do this a lot in Calc 2, by the way. Calc 2, when you do sequences, instead of x, you have n. And n goes to infinity every single time. So you learn to love it. This means that as x, so that gets small. So instead of grows without bound, anyone know what a good word could be? Shrinks or decreases. Yeah, decreases. X decreases. Decreases. Means that as x decreases without bound, I just think gets small or shrinks. F of x approaches L. F of x approaches L. In this case, we also have a horizontal asymptote. This is also going to give us an HA. We have an HA. We have an HA. HA means horizontal asymptote at y equals L. So this means we also have a horizontal asymptote at y equals L. Okay? They both mean that. You can have functions with two horizontal asymptotes. It's not something you're used to. Maybe in trig you saw it, maybe not. Like arctangent is an example of a graph with two HAs. But so here's an example. Let me actually give you an example. That example. If you have y equals the arctangent of x. So the arctangent graph is actually one of the most important graphs in Calc 2, believe it or not. Even though you take trig, you barely even talk about it. It's been a while since I've taught trig, but I mean, I mention it, but I never test them on it. So arctangent looks like this. It has a horizontal asymptote here, and it has one here like this. Whoa, I was looking away and I drew a line that's not straight. It's better. There we go. And so it looks like this. Like that. That's the graph of arctangent. And this line here is pi over 2. And this line here is negative pi over 2. So eventually you memorize it because it just comes up so much. It's one of those things. That's how I know it, because it comes up. So if you take the limit as x approaches infinity of arctangent of x, Well, when x gets really, 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 really big, the y values get close to pi over 2. So it's equal to pi over 2. So y equals pi over 2 is a horizontal asymptote of arctangent. Likewise, I'll do the other one. Limit x goes to negative infinity of the arctangent of x. And this is equal to negative pi over 2. So y equals negative pi over 2 is also a horizontal asymptote of arctangent. So arctangent is one of the first functions that you maybe see that has two horizontal asymptotes. It's kind of weird. It's kind of weird. Usually, like in college algebra, they all have one. They all have one. So it's kind of deep. Who here had never seen the arctang graph? I'm just curious. Never seen it? You've never seen it? Yeah, it's kind of weird. Yeah, it's kind of a weird graph. But it comes up enough to where it's like, whoa. It comes up in Calc 2 a lot. Yep. It's more popular than arcsine, arccosine. It's the most popular arc graph there is. Most popular one. All right, maybe we should do some homework. Let me see if I can sign in and we'll do some problems. Oh, sometimes you can have an infinity here, right? If you have an infinity here, obviously you don't have an HA. It just means that f of x gets really big too. So it's the same thing. So let's see. Sign in. All right. Let's see. Calculus 1. Wow, so much homework. So many, well, sections, I mean. Let me click on the 3 or 5. Wonder how many problems there are. 14. Oh, wow. Wow, the homework is good. Yeah, we should do number 1 from the homework. It's actually really good. Let's do it. I was going to make some up because I thought the homework might not be that good, but number 1's pretty good. It's a nice problem. It'll be like a good refresher of some stuff. So number 1 from the homework, it's 3 parts. By the way, does anyone have the homework up? Anyone already have it up? You're about to? Cool. Thanks. Good. Extra credit. No, I'm kidding. But limit x goes to infinity. Let me go look for it. Let's see. X to the 6 plus 1 over, I already forgot. X to the 6 minus 2. Thanks. Thanks. Did I make mistakes last time, by the way? Did I make, did you all get points for my mistakes? Do you remember?
Yes.
Was a couple? 3? Something? No. 12? No, it's not 12. Was it really?
Yeah, you made 4 mistakes at the end of class last
Are you serious?
Everyone left.
What?
There's only like 10 of us still in here.
I don't remember that. Really?
Yeah.
Okay.
There's like 2 on 1 question.
Oh, on the board over here? Yeah, so for those of you that left, you also get points. So, yeah, okay, all right. So just remind me after class and I'll write it down, okay? Please, because I'll forget. Yeah, it's good. You might need them. So that's cool. So I don't know if I probably shouldn't have done this as the first example, but do you all know? Yeah, if you have something like this, whenever the degrees are the same, if you have something like this, 5x to the 4th. Do you remember this when you were taking pre-calc? When you're looking for horizontal asymptotes, whenever the degrees are the same, you just divide the numbers. It's the ratio of the coefficients. So it'd be like 2 over 5. Right? It's that number over. So whenever they match, you get that. The reason is this. This is growing at the same rate as this because they're both 4th degree. So in the long run, it's just basically that, 2 over 5. So you just worry about those. So here, it would just be 1 over 1. So the answer is just 1. That's it.
So these problems are just finding the horizontal asymptote?
Or the limit. Yeah, which is also the horizontal asymptote in this case. So on your test, I should probably emphasize this. You will have a couple limits where you don't have to show work. It'll say find the limit, don't show work. These are examples of those problems. Okay, so no work. I won't require any work on something like this. Let's suppose that you wanted to show the work on something like this. Let me show you just so you see it once in your life. It's good to see it once, just so you say you've seen it. So another way. Some teachers require that people show work for these. I don't think that's, I don't know. I think it's a waste of time. Basically, I'll show every single step. We're going to multiply by 1 in a really clever way. So we multiply by 1 over x to the 6th over 1 over x to the 6th. That's really what's happening. It's really sneaky. Again, this is not necessary. You never have to do this on the test. But it's good to see it. Build character. Then you distribute the 1 over x to the 6th. So 1 over x to the 6th times x to the 6th is going to give you 1. So it's 1 plus. Then this times this is 1 over x to the 6th over. This times this is 1 minus, and then this times this is 2 over x to the 6th. See how we did that? It does actually, this does come up in some other harder problems, so it's worth doing. But on these, you can just do 1 over 1 and you get 1. And so now you see, I probably should have gone over this, but if you have 1 over x to the 6th, when x gets really, really big, this fraction gets really, really, what do you think? Small. Good. And if you don't understand that, it's okay. Think about the number 10. 1 over 10 is 0.1. 1 over 100 is 0.01. 1 over 1,000 is 0.001. So the bigger the bottom gets, the smaller the fraction gets. So this is equal to, you drop the limit sign, 1 plus 0, 1 minus 0, 1 over 1, which is equal to 1. So same thing. Same.
Equal to 0, 1 plus, why is it 0?
Because what happens here, when x gets really, really big, you have 1 over a number that's really, really big.
Oh, so you're just essentially putting infinity there.
You're not actually plugging it in. So good point, good comment. So if you have something like this, the question is, what does this get really close to when x gets really, 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 really big? This gets really close to 0, so you put equals 0. Okay. Yeah, some people will do this. That's bad. Good. Yeah, I'm glad you asked. So you're not supposed to plug it in. Okay. Good, yeah. Yep. Any questions on this one? All right, B, let's do B. So it's the limit as x approaches infinity of x to the 6th plus 1 over x to the 7th minus 2, I believe. Is that right? Minus 2? Thanks, Josh. Josh, is it Josh? Yeah. Really? Okay. So this time the degree is bigger on the bottom. The degree is 7 on the bottom. So the bottom is growing faster. So what do you think the answer would be in this case, if you had to guess? 0, yeah. So whenever the bottom grows faster, the fraction gets closer to 0. So this is 0 in this case, because the bottom is getting bigger faster than the top. So it's kind of like this, right? The bottom gets bigger faster than the top. So whenever the number is bigger on the bottom, the answer is 0. Okay. So if they're the same, you just divide. If it's bigger on the bottom, the answer is always 0. If you wanted to write the horizontal asymptote, it would be y equals 0. The question doesn't ask that, but if you wanted to, the HA here would be y equals 0. Okay, if you wanted to do it. Here the HA would be y equals 1. Okay, C. Limit x approaches infinity, x to the 6th plus 1 over x to the 5th minus 2. What do you think?
So the top is bigger.
The top is bigger. Yep. So, and you know what it's going to be equal to? Infinity. Yeah, I didn't think anyone would say the right answer. Yeah. I wasn't expecting that. Yeah, good. Infinity. The answer is infinity. So you don't have to show the work here. Here's the idea. This is not correct work, but here's the idea. If you have x to the 6th plus 1 over x to the 5th minus 2, this is good for intuition. The thing is, x is getting really, really big. So who cares about the 1 and the 2? You can ignore them. This is approximately equal to x to the 6th over x to the 5th. Right? Because who cares about the 1 and the 2? X is huge. X would be like 20 billion. Right? 20 billion to the 6 plus 1. I mean, who cares about the 1? But this is x. So when x is big, this is like x. So when x approaches infinity, this approaches infinity. Boom. Do the same thing here, right? When x is really big, who cares about the 1 and the 2? So x to the 6th plus 1 over x to the 6th minus 2 is approximately x to the 6th over x to the 6th. That's just 1. Boom, answer is 1. Works every single time. Every single time. Even in the hard ones. If you think about it the right way, you'll always get the answer that way. That's how you build intuition. But that's not correct, right? It's not like correct math. However, on the test, you won't have to show any work on these. So I think it's good to be able to have this type of intuition. It's good. Any questions on this one? That was number one. Number one. John. Oh, we should do it. We should do number 2 because I don't want to do it. We should do it. Number 2. Number 2. Number 2. So it's 3 parts again. A, limit x to, is it to infinity in this case? Yes. It is? Can someone read me the top?
2 minus 3x. And then 3x cubed minus 4.
Thank you. 3x cubed minus 4?
2x cubed.
2x cubed minus 4? Like this? Huh, okay. Ooh, maybe we should use our little wavy skill, what we did earlier with the little approximate symbol. That was pretty good. It made a lot of sense to me because you don't have to show work here. But then again, we don't even have to do that because what's the answer going to be in this case? 0. Why? Yeah, it's so easy because of the 3, right? The bottom is bigger, so we get 0. That's fun. I haven't looked at the homework since last year, so this is refreshing. So 0. I usually don't look at the homework before class, ever. So I just kept it from last year. So that's that one. Let's do B. Limit x approaches infinity, 2 minus 3x, I think. And then 2x minus 4. I like how when I go over there, it doesn't follow me. That's why I stopped it from following me. I couldn't handle it. I already forgot it. 2x minus 4. See, I feel free. I feel like I can move. I can walk over here. Look, it doesn't see me. In this case, negative 3 over 2. Yeah, right. Because they match. Right. It's 1 and 1. So it's negative 3 over 2. It's beautiful. It's beautiful. Super useful. Super useful math. Again, you'll have a bunch of these on your test, a couple, like 3 or 4 or 5. Usually it's 3 of these, like 9 points or something. C. Limit x goes to infinity, 2 minus 3x squared over 2x minus 4. 2x minus 4. It's having fun running back and forth, having that follow me. It's great. I think that for this one, I'm going to do that thing with the squiggly line because this is making me uncomfortable, this negative 3. It's going to kind of like mess stuff up. So let's see. So I'm going to do some thinking. So thinking. So we have 2 minus 3x squared over 2x minus 4. So we can drop the numbers. So this is approximately equal to negative 3x squared over 2x, right? Because you can drop the numbers. I believe so, because this is negative 3 halves times x. And this is x is approaching infinity, so this will approach negative infinity. Isn't that powerful, that little thing, when we think as x approaches infinity? So the answer is negative infinity. Beautiful. Yeah?
Bottom was negative, would it be positive?
If you had like a negative 2x here, yeah, because then it would become a positive. Yep, good. Nice problem. A little bit harder. So this intuition is really important. Any questions on these? Anyone like these besides me? I'm really liking these for some reason. I didn't even know, I knew we were doing limits today. Well, I knew it when I looked at the thing, but I didn't think there'd be these. I forgot about this until like now. So kind of fun. Number 3, it's kind of this, I don't know, maybe we should do it. Let's do it. If I think we should do it, we probably should do it. We should do it. Number 3. In the next section, we're only going to do 1 problem. Yeah, we'll talk about why. Yeah, you'll see. Oh yeah. The next section, I think there's like 9 homework problems maybe. I don't know. They're like epic. Each one is like a task. Limit as x goes to infinity. And what's the top in this case?
5x to the power of 3 over 2. And then 6x squared plus 3.
Plus 3, like this? Cool. Thank you, Josh. So 2 is 4 over 2. So the bottom is bigger in this case. 0. Yeah, piece of cake. 0. Right? Because the bottom is bigger. Whenever the degree is bigger on the bottom, you get 0 as the answer. Really, really nice. Really, that's part A. That's part A. Let's do B. Limit x goes to infinity. 5, same thing on the top. 5x to the 3 halves. On the bottom we have 6x to the 3 halves plus 3. 5 over 6, yeah, very good, because they match. Right, they're the same degree. Same powers. So this is 5 over 6. That's it. It's kind of nice. I like these. I like easy math. C. I was doing some harder problems in my other class and I was messing up today, so this is a nice, well, I haven't messed up yet, so, but maybe I won't. 5x to the 3 halves. And then on the bottom, it's 6 square root of x plus 3. Interesting. Positive infinity, yeah, good. Positive infinity, because it's bigger up top, and you can do the thinking thing. Like you can do the, I like writing thinking now on the board. It's kind of fun. Thinking, like, oh, it's a thing. Thinking. So 5x to the 3 halves. I don't know what else to write. And then you write 6x to the 1 half plus 3. So we can drop the, which one can we drop? The 3. Yeah, you can drop the 3. So this is 5x to the 3 halves, 6x to the 1 half. And x to the, what you do here is you subtract 3 halves minus 1 half is 2 halves. So you just get x. This is 5/6 x. And so that goes to infinity as x goes to infinity. So nice stuff. Yeah, Ethan.
Where would be negative infinity on the bottom?
That's a good question. That's what I was just thinking, Ethan. You read my mind, actually. I was just thinking the same thing. It's kind of creepy. Yeah, it's like I was just thinking, like, are there any with negative infinity? Because we've done 3 of them, and they all have infinity. And yeah, there should be. Let's see. Let me scroll down. Okay, it's not the next one, but let's do the next one anyways, and we'll get to it. So I think we should do the next one because it's easy, and why not? Yeah, there should be some with negative infinity. They're a lot harder, Ethan. This is really beneficial. Whenever it's negative infinity, you definitely want to do this just to make sure you don't mess up. So 4, limit as x goes to infinity of 5 to 5 plus 6 over x. This is really easy. Ooh. Yeah, we'll do number 5 after this. Number 5 is really annoying. It has a negative infinity and it's tricky. So it's just 5. Yeah, good, Logan. It's just 5. Because this 5 is just 5. And then this approaches 0. So this is equal to 5 plus 0. Because this, as x gets really big, 5 is always 5. And this piece approaches 0. So you just get 5, as Logan said. And that would be the final answer. That's it. Number 5. Number 5. This one's kind of annoying. I remember the first time I ever saw this problem in the homework, I thought, oh, I almost didn't assign it, but I thought, no, it's okay. We could do it. It's kind of, it's instructive. There's no way to show the work for this one. That's the problem. That's why when I first saw this in the homework years ago, I was like, like, how do you show the work? You'd have to prove it, which we're not going to do. So the first piece approaches 0. And then what do you think this is going to approach when x goes to negative infinity? What do you think the answer is? Infinity. Yeah, it's infinity because x is approaching negative infinity and it's already negative. So negative and negative is positive. So this is going to be infinity. Right, because this piece here approaches 0. And this piece here approaches infinity. Because negative and negative is positive. Do you see it? That this is 0. And this one is negative infinity, but negative and negative is positive. So you just get infinity. So you get infinity. Kind of a hard one to think about, so a little bit harder. Any questions on this one? Everyone see why this is 0? Because it's 5 over something big. And then again, this negative x over 6, x is approaching negative infinity, so this is going to approach infinity. That's the idea. Okay, a little bit sneaky. Number 6 is really easy, but I mean, we're just going down the line. Let's just keep going. I mean, let's do it. Number 6. I think it's 14. They're going to start getting really hard at some point. We're just not there yet, which is good. So number 6. Like there should be some really tough ones.
I have a question on number 5. Why wouldn't it be negative infinity where the second part is?
This here?
Yeah, what's the negative sign?
Oh, because x is approaching negative infinity. Ah, yeah. So negative and negative is positive. Yeah, good question. You see it?
Yeah.
It's tough. It's good. Limit as x goes to infinity of 2x plus 5 over 3x minus 8. So 2x plus 5 over 3x minus 8. 2x plus 5, 3x minus 8. That clock on the wall is still wrong. I guess because they changed the time yesterday. 2 over 3. Very good. Because it's the degrees are the same, so the answer is it's the ratio of the leading coefficients. These are called leading coefficients because of the numbers in front of the terms that have the highest degree. So 2/3. So when someone asks you, hey, why is it 2 over 3? You can say, because the degrees are the same, the answer is the ratio of the leading coefficients. It's a really easy way to say it without having to write down a formula. Ratio of the leading coefficients. 7, we should just do it for completeness since it's easy and we're going down the line. Limit, x approaches infinity. Can you read me the top, Josh? Can you, number 7?
Number 7. 5x squared plus x over 6x cubed plus 4x squared plus x.
That's a lot of writing for something so easy. Oh, I don't know. I don't know if it's that easy, right? It's like, what do you think the answer could possibly be? 0. Why is it 0? Yeah, it's bigger on the bottom, right? The degree is bigger on the bottom, so the answer is 0. It took longer to write down the problem than it did to do it, right? So whenever the degree is bigger on the bottom, the answer is 0.
Did you always go by the highest degree?
Yes. Yeah.
If we took out the 6x3, it would just be, you'd have to be 5 over 4.
Right, so if this wasn't here, the answer would be 5 over 4. That was a really good question. Good question, Jack. Right, okay, yeah, so Jack had, yeah. I almost called you Jesus, but that's like your middle name. Yeah, so 5 over 4, yeah. I had a friend named Jesus when I was a kid, yeah. So every time I grade your test, I'm like, oh, like, Jesus, like, oh, like we used to play basketball. Okay, number 8, let's do number 8. Number 8, yeah. Limit, x goes to infinity. Why not? Yeah, 7x cubed plus 5 over 21 x cubed minus 2x squared plus 2. Yeah, I memorized the last part. I was like, oh, plus 2. What do you think? 1/3. Oh, skipping steps. No, but that's fine. Yeah, because it's 7 over 21, which is 1/3. Yeah, good. No, good. I was like, we're really on top of things. Not only do you know how to do it, you can simplify it. It's really good. Yep, because the degrees are the same, so it's the ratio of the leading coefficients. Very good. So it's 1/3. Good stuff. I can't believe we've done 8 problems. I feel like we've done so much. Okay, game over. Number 9. Here we go. This is where the fun ends. Any questions on the first 8? Questions on the first 8. So on questions like this, you don't have to show work. A problem like number 9, though, it would be a separate question. It would be like its own question on the test. It would say, please show all your work carefully. Like it would say, carefully show all steps. It's like an 8-pointer. Let's do it. Let's do it. This problem is really tough. I was thinking, how do you do it? I figured it out. Okay, so let's do it. Number 9. It's like, I forgot how to do it. But now I got it. This problem is really hard in Calc 2. You see this problem in a Calc 2 class. It's very common, except in Calc 2 it's harder. And the reason it's harder in Calc 2 is because you know more in Calc 2. So you know something called L'Hopital's rule in Calc 2, and This is a L'Hopital's killer. It's like a trap, because you can't use L'Hopital's rule on this. X squared minus x. So this is probably one of the hardest ones in the homework. I should have shown you all L'Hopital's rule for fun before doing this. That would have been cool to see. Do you all want to see L'Hopital's rule really quick? Just for fun on the side? I'm going to show you. Yeah? Yeah? And then, because this is like a L'Hopital killer. This is like, yeah. So check it out, just a quick aside. Before we do this problem, I'll just show you how to do it. Say you have 2x plus 1 over 3x plus 2. So L'Hopital's rule says, this sounds really bad, but if you plug in infinity, you get infinity up top. And you plug in infinity on the bottom, you get infinity on the bottom. So this is called an indeterminate form. So you have something that looks like this, infinity over infinity. So whenever you have this form, you can use something called L'Hopital's rule. It basically says you put an equal sign here, you put the limit here, and then you just take the derivative. The derivative of 2x plus 1 is 2. The derivative of 3x plus 2 is 3. And then when you take the limit of a number, you just get 2 over 3. That's Calc 2. It's called L'Hopital's rule, or Hospitals, or hospitals, depending on how you say it. So whenever you have infinity over infinity, you can just take the derivative, take the derivative. Check this out. This is going to bring back some memories. Sine 2x, sine 5x. This was like a really hard question for the first test. I don't think it would ever made it to your test. I didn't put it on your test, but we did it in class. It was really tough. If you plug in 0 here, you get sine 0 over sine 0. Sine of 0 is 0. So you get 0 over 0. So whenever you have the form 0 over 0, you can use L'Hopital's rule. So L'Hopital's rule works when you have infinity over infinity or 0 over 0. You can also do infinity over negative infinity, stuff like that. But you got to have 2 infinities or 2 zeros. So we take the derivative. It's really powerful. What's the derivative of sine? Do you remember?
Cosine.
Cosine, yeah. So it's cosine 2x, and then we use the chain rule. So we multiply times 2. Yeah, it's the derivative of the inside. Now on the bottom, same thing, cosine 5x. This would have made the first test much easier, especially the ones with the sine x over x, because you could just use L'Hopital's and blow through them. People love L'Hopital's rule because it's so easy. Like once you know how to do it, it's like boom. And then now you can just plug in 0, because cosine of 0 is 1. So you get cosine 0 times 2 over cosine 0 times 5. This way when you go to Calc 2, you know some extra stuff. Cosine of 0 is 1. So you just get 1 times 2, and you get 1 times 5. So you get 2/5. And if you remember from the first test, I remember some people were saying, like Nick was noticing that, oh yeah, isn't it always 2 over 5? You had noticed that. So now you know why. L'Hopital's rule. But this is infinity over infinity if you plug in negative infinity, but it doesn't work. The L'Hopital's killer. So this destroys Calc 2 students because they get used to this, and then all of a sudden this shows up in the homework. It's like, what? So L'Hopital's rule, just really, really cool. It's spelled, I think it's spelled like this. L. People call it hospital's rule. I think you can put an S there. Oh, and there's like a funny symbol here. I'm probably doing it wrong, so, but.
Does it actually, because that's the French word for hospital, so.
Oh yeah, okay.
So is it like actually meant to be about like hospitals?
No, it was a guy, I think.
So that's just his name?
He was a surgeon. No, I'm kidding, no. Yeah, I know. You should look it up. I used to know the correct spell. You speak French?
I know a bit.
Oh, cool. Very good, good. That's cool. I wish I spoke French, but I don't, so. But yeah, so yeah, there's multiple spellings of it too, I think. Is that how you spell it? Is that right?
Not quite, but it's really close.
Okay.
I think the accent symbol.
Yeah, what's the accent symbol? Do you know? It's like 2 dots or
I think
something?
there is one.
Oh, okay.
No, like, yeah.
Okay. It's just, all right. Any questions on L'Hopital's rule? So it's really powerful. It's really cool stuff. So yeah. All right. So let's do this problem. So how do you do this problem? This problem, L'Hopital's will not work. How do I know that? Because I've done it. But a normal person, like in a regular class, be like, oh, L'Hopital's. And you know, if you do L'Hopital's, if you do it twice, you end up with the same thing. It's like a death loop. So how do you do it? You have to use this. So recall that the square root of x squared, maybe you don't know this, so I'm saying recall, and you might not know, just pretend you did, is equal to the absolute value of x. When I study hard stuff sometimes, I pretend I knew it, even though I didn't, and I try to like trick myself. And this is equal to x if x is greater than or equal to 0. And I think we've done this part. If x is less than 0. I don't think you've seen this. So we're going to use this to do this problem. So the idea is when you see a problem like this on your test, right? If you're taking the test, you see something like this, you want to divide everything by this. So let's think about which piece we're using here. So since x is approaching negative infinity, the square root of x squared, well, it's equal to the absolute value of x, but x is less than 0, so we're going to use this piece. I'm going to put this in a box. That's key. That's the key step. Okay. So if you were approaching infinity instead, what would go here instead? X, positive x. Right, good. So you just memorize it. So when it's approaching negative infinity, this is negative x. If it's approaching positive infinity, it's x. Okay, so to do it, I'm just going to start doing it up here. We're going to take that same trick that I showed you at the beginning. So we're basically going to multiply by 1 over something, and then here, 1 over something. But it has to be the same thing. So on this piece here, I'm going to use the square root of x squared, because I want to combine these at some point. But up here, I don't want to use the square root of x squared. So instead, I'm going to use negative x, because they're the same thing. Isn't that clever? So it's the same thing. You can put square root of x squared here if you want, but it provides no benefit to you in any way. Like, it doesn't help us. So it's really clever. So this is a really powerful technique, doing a problem like this. You can also do it using intuition, which we'll talk about later, but it's good to see it this way. So again, it's really this. It's the same thing, but we purposely put negative x there so stuff cancels. So let me show you the next step. Maybe that'll add some clarity to everything. So this is the limit as x approaches negative infinity. And I'm barely going to do anything. I'm just going to write it like this. I know it's just negative 1. I'm being really like showing a lot of steps. And then I'm just going to do it like this. I didn't really do anything. I just performed the multiplication. I'm showing extra steps on purpose. You can skip steps here. I'm just showing extra steps. Because this is hard. This is supposed to be really hard. Like, this is a hard problem. It's a hard test question. So this is the limit as x approaches negative infinity. So when these cancel, you're just going to get negative 1 up top. And then here, you can bring, because they're both in square roots, you can combine them. I'm pretty sure this is in the book, and they skip all these steps. So this is x squared minus x over x squared, right? Because you can combine them. That's why we did that. That was the idea. So we can put those square roots together. It's really beautiful problem. I think it's beautiful. This is nice. This is math. This is the limit as x approaches negative infinity, negative 1. Now we can just use algebra in the denominator, because it's this over this minus this over this. So this over this is just 1. So awesome. Minus, and then this over this is 1 over x. Any questions? I'm going to pause here for a moment, because this is tough. Really, really fancy technique. And again, how would you know to do this in a testing situation? Because it looks like this. You have these weird square roots. You'll get used to it. It doesn't look like the other ones, so you'll know. Plus, it'll say show work. Carefully show your work. So now we can take the limit. It's a little more clear now. So we could drop the limit sign. This is negative 1 over. Here, when x approaches negative infinity, this approaches 0. So it's square root 1 minus 0 equal to square root of 1 is 1. So we get negative 1 over 1. So we just get negative 1. That's it. That's it. That's it. Yes?
Once you know that the x squared on the bottom is negative 1, couldn't you just do the step where you do x over, it would just be the coefficient 1 over negative 1 equals negative 1? And then skip all the other.
Yeah, but you could. Yeah, but on the test it'll say show work. Yeah, but you could. We're going to do it that way now. Good. Rachel, was that? Oh, what is it, Sarah? I'm sorry, Sarah. Yeah, Sarah's really smart. So Sarah is saying, yeah, it's clear. So Sarah's way. Did I spell your name right?
Yeah.
Okay, cool. Because some Sarahs don't have H's in their names. No, they do like the Sarah without the H? Oh, yeah, it's weak. Okay, so I'm thinking you meant this. Let's see. Let's try Sarah. I hope I do it right. Let's see. So Sarah's way we can drop this x, right? Is that what you were thinking? So then this is x over square root of x squared. But we know that's negative x. So it's x over negative x. So it's just negative 1. Boom. Sarah's way. Yep. Is that what you're thinking? Yeah, pro. Yep, good. So that's the easy, that's without showing work. So the formal way to do it would be like this. Huh? No, this is not showing work, but it's beautiful. So one time, true story, I sat in on another teacher's class. She doesn't work here anymore, but she was really good. She had a PhD, really nice lady. She's awesome. And I sat in on her calculus class because she needed me to do something. I forgot what it was. And she got me a gift card for going, but it was great. Anyways, she was teaching this, and she didn't do it this way. Instead, she did like 5 examples Sarah's way. I thought, oh, wow, it's cool, because she's building intuition, because this is intuitive. So this is really good. It's really good. Good. But on your test, sorry, you'll have one where you have to show work, just because it's good for you. Like, it's a build character. No. Good. I was going to call you Arnold, but that's not your name. No. No, doesn't matter. Austin. Number 10. Let's do number 10. Do you all want to try number 10? You do? Okay, all right. Yeah, number 10. Let's see. So it's the limit as x approaches infinity. This is one of the ones like the one we just did. Square root 5x. No, not 5x. X squared. Sorry. X squared. Minus, do you have it up, Josh? Minus 5. How do you know what it is? Oh, it's on your phone? Oh, high tech. Okay, over
5x minus 3.
5x minus 3. It's cool. I turn my phone off when I get here, I guess, so I don't. Yeah, no one calls me anyway. So you try it. Do it the long way. Don't do it Sarah's way. I mean, you can do it Sarah's way if you want, because it's faster, but on a test, show work. So I'm gonna do it. I can't take it anymore. Solution. Who got the answer? What did you all get for the answer? 1/5. Yeah, so I'll do it the long way. So limit. Now I really want to do it Sarah's way, but no, it's a classroom. Like you're supposed to learn, huh? I know. We're supposed to just one on your test. Just one where you do it the long way. So I'll feel bad if. So basically, I'm just going to skip the steps. So basically, in the numerator, you want to divide by the square root of x squared. And the denominator, you want to divide by x. And the reason you can do this, okay, so let me just explain this because I just jumped into it without explaining it. The reason you can do this is because, as before, the square root of x squared is equal to the absolute value of x, and that's equal to a piecewise function. It's equal to x if x is greater than or equal to 0, and it's equal to minus x if x is less than 0. So just like the previous example, this is the case. And so in this particular case, x is approaching infinity. So because x is approaching infinity, that means x is positive. Hey, what's up? Oh, you're back. So then the square root of x squared, well, x is positive, so we use x. Hey. So does that make sense? Any questions on that part? Okay, hey, all right, 3 people. All right, so this is equal to the limit as x goes to infinity. So now you can combine these. This will be the square root of x squared minus 5 over x squared over, and then here you can just do 5 minus 3 over x. Good. This is equal to the limit. Oh, it's already been over an hour. X goes to infinity. So this will be x squared over x squared, so that's 1. 1 minus 5 over x squared over, and then I'll just write this piece again. I really like how this thing is not following me. I feel like I can move around. So nice. I feel like I'm free. Like, I just do whatever. I can walk away. I can say anything. Doesn't matter. So nice. This is 0 and this is 0. So it's going to be square root 1 minus 0. Notice how we dropped the limit sign, right? It's really important on questions like this. 5 minus 0. So you get the square root of 1 over 5. So you just get 1 over 5, and that would be the answer. It's like at least 8 points on the test, something like this. So quite a bit of points. I know Sarah's way is easier. It's really important to be able to do it Sarah's way. If you do it Sarah's way, I'll give you some points, right? But like to get full credit, please show the work, go through all the steps. This is important and useful in other areas of math. So it's good to see it.
Can you do this one Sarah's way real quick?
Yeah. So Sarah's way.
So which way is easy?
Well, Sarah's way is the easiest way, but technically Sarah's way, like it's not like showing work carefully. It's not super correct. It's just,
Like a cheating way.
yeah, it's like a cheating way. I mean, sorry, Sarah. So Sarah's method, the ancient method. Yeah, well, yeah, I don't know. It's cooler when you call it ancient. It doesn't matter what it is. So the ancient method of Sarah. So basically, you drop the numbers. So you get square root of x squared over 5x. Now, you still have to know some stuff to do it Sarah's way. It's not cheap. I mean, it is, but like, not really. Like, you still have to know this. Like, you still got to know some stuff. So you got to know that that's x. Oh, look how good that is. Look at that. So awesome. Yeah.
We could use it to check our answer.
Yes. Yes, and it's really good. It's really good to be able to do this. Like, it's powerful. Yeah, I just want you to, this is a Calc 1 class, just at least one where you formally go through it and write the limit sign every time, carefully do it. Just one. Just one. Any questions on that one? Okay, let's just do a couple more, then we'll take a break. Let's do, because I know you probably want a break. Number 11. Number 11. The next section's easy. Well, it's not easy. We'll do one problem in the next section, and that's it. They're really long. There's nothing new in the next section, but it's worth being here for it. So it's the limit as x goes to infinity. And does anyone have number 11?
6 over 5x plus sine of x.
Oh, thank you. Oh, what a nice problem. So we can't really show work. Well, we won't show work on this one. Oh, nice. There were some harder ones in the homework and they're not there. Oh, it's a good day. It's a good day. I was expecting harder ones. So what do you think the answer would be in this case? 0. Yeah, the answer is 0. And I'll explain it. So basically the idea is, the top is just 6. Sine x is a wave function. It just does this. So it's trapped between -1 and 1. And then this is getting really, really big. So you have a number over something getting really, really, really big. So this is getting really close to 0. So on something like this, you wouldn't have to show work. It's a great question for a test, but let's do 12. 12 is also a great question. You don't have to show work for something like this either, but I'll show you the work. Limit x goes to infinity 5 cosine of 5 over 4x. I believe if you look at the old exam that's on the internet, I think you have a question like this on it. This is a really good one.
I like that.
Me too. It's really cool looking and it's not hard. Do you know how to do it?
Yeah, we got the answer.
Oh, so good. What'd you get?
We got 5.
Yeah, it's 5. Good. So x is approaching infinity. So 5 over 4x approaches 0. So you get 5 cosine 0. What's the cosine of 0? 1! Yes, 1! So you just get 5 times 1, so you just get 5. Boom. That's it. And that's it. Let's do 13. Why not? Let's do it for completeness. 13. Limit x approaches infinity of
Sine of 5x.
sine of 5x over x. We've done every single homework problem, haven't we, so far today? Wow, what is going on? Yeah, we've done like all 13. It's pretty good, I guess.
Just 14.
This is 14, yeah. We still have to do that one, I guess. So, yeah, we'll do it, I guess, if you wanted, yeah. So I'm at a, like, I don't know what to do. So there's a way to show work for this, but you can do it in your head. So first, does anyone know what the answer is? 0. Yeah, it's 0. Because, yeah, sine of 5x is between -1 and 1, so it's not going to get super big. And x is approaching infinity, so, yeah. Do you want to see how to show the work or no? No? You really don't? Yes? Yes, extra credit. No, I'm kidding. No. Let me show you. No, you don't need it. Okay, I don't want to mess up now. So another way. Now, since I've shown you the easy way, don't worry about showing work on the test on this one. Okay, don't worry about it because you already did it on the first test. So sine is trapped between 1 and -1. Anyone know what we're doing? What are we going? Squeeze! Yes, the squeeze theorem. Ah, so good. So we got to make it match. So we divide everything by x. Again, on your exam, I won't require that you show the work on this one. Just give you a break. You've got enough stuff going on this next test, and there's so much stuff. It's like, oh. Then you're supposed to take the limit here, take the limit here. So you take the limit here. As x goes to infinity, you get 0. Then you do it here. So basically, you create the inequality. So you start off by recognizing that sine is between -1 and 1. You say, OK, I don't have sine in this problem. I have sine of 5x over x. So you divide everything by x. X, 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 x. You take this limit, you get 0. You take this limit, you get 0. So thus, the limit of whatever's in the middle is also equal to 0 by the squeeze theorem. The squeeze theorem. Do you remember the other names for the squeeze theorem? Sandwich and pinching theorem. Yeah, I'm really hungry now. So yeah, those are the two other names. I don't like the word pinching, but that's a thing. I've had people like take tests, not in this class, by the pinching theorem. I'm like, oh. No one likes to be pinched. Well, some people might, but any questions on 13? So on an exam, I'm okay with just the answer on this one. The only one I really want to see work is the one with the square root so far. So that way there's like so you know what to study for. Do you want to do 14 for completeness? You want to do it? Yes, let's do it. 14. So number 14. I don't think we've ever had a section where we've done all the homework. This is like a first in this class, right? First time. We haven't, right?
Well, 2.6.
We have? What section did we do all the homework in?
I think 2.6 you gave us.
You gave us all the answers.
I gave you all the answers? So I'm recording that. No one watches this anyways.
Except for one person gives you.
Except for like.
I still watched it.
I watched a bunch of them.
Did you really? Yeah.
I just like put them on in the background, but I guess.
Oh.
And I'm like, and at least like I can like inundate my brain with like general information.
Yeah, you hear the. It might help. It might. It probably does. Yeah. So on this one, let's go ahead and do it. This is the one we have to show the work, right? The long ones. So I'll just do it. I'll show you how to do it. So recall that the square root of x squared is equal to the absolute value of x. I'll just go through all the work again, which is a piecewise function, which is x. So this is what we use. And if you're wondering why I'm writing it again, I just figured, let me just write it again just as a refresher. So that's what we're using in this problem. So you'll know it's one of these because you have the square roots. Okay. All right. So now we have to show the work. So because x is approaching negative infinity, that means x is less than 0, right? Because we're going to negative.
Are we supposed to memorize the read point?
Yeah, you should. Yeah, you should. Well, yeah, you don't have to. Yes. Okay. Yes. Yeah, you don't have to write it down, but you should. Go ahead. Get out of the way. I don't know why I'm getting out of the way. I'm already. Yeah. Okay. Like, what's this even matter? So then the square root of x squared. Oh, what would it be in this case? Would it be x or negative x? Negative x. Very good. This is really important. So again, I feel a little bit bad because Sarah's way is so good. Sarah, really awesome. But it's important to show the work at least one time in your life. You know, it's a good way to think about it. The one time in your life. So we're going to multiply by 1 over the square root of this. So I'll show that step. I'll even show it like this. I know I could have skipped a step here, but I didn't because I'm weak. So here, we don't want it to be square root of x squared. What do we want it to be in this piece? Negative x. That's what we want. So we make it what we want it because we can do that because we're pro. So I'm going to put it down here. So I just distributed it and put that thing. That's a x squared. Put that down there. Over, and then same thing. Put this down here. This would be square root of x squared plus x.
Wait, why do you put square x twice?
Here, here, and here. Oh, because we're multiplying by 1. Look. Yeah, I know. I just wanted to show an extra step.
Okay.
I turned it into negative x over here. If I was doing this like on my own, I would have done this. Like normally I'd do this. But I just showed an extra step because I felt bad. So this is equal to, I am so hungry. This is x approaches negative infinity. Negative 5x over negative x is going to be 5, right? Because they're both negative, is that right? 5 minus 5 over x. I haven't messed up today. I feel like I'm going to. And then you can combine these using the same square root. This would be x squared plus x over x squared. So now this is equal to the limit, as x approaches negative infinity, of 5 minus 5x over square root. X squared over x squared is 1 plus 1 over x. You're very good. So we're here. And so now we're in a good place. Because now we can take the limit. This is going to be 0, so we just get 5 over the square root. It's 5 minus 0
Plus 0.
over 1 plus 0. Wow. It wouldn't matter. Plus 0 is the same thing as minus 0, but you're right. It should be a plus 0. Yeah, it doesn't matter though. No, because this is just 0, so yeah, it doesn't matter. I'll leave it as minus. This is 5 over the square root of 1, which is just 5. Let's do it Sarah's way. So Sarah's way, the ancient method of Sarah, would be to write down this without the limit. And then you can drop the lesser degree terms. So you drop the 5, so you get this. And then here you drop the x, so you get this. So Sarah's way may be a cheap way to do it, but you still have to know stuff. Because what's the square root of x squared going to become? Negative x. So you still have to know that, right? So you still have to know what John was talking about, right? Even when you use Sarah's way. So even when you use this ancient method, you still must know stuff. So.
Wait, so if we did it that way?
You get some points, but not all of them. I mean, it's like a test. I want you to it's a calculus 1 class. You know, it's a test. And, you know, I have to, yeah. Just one time, John. Just one. Let's take 15 minutes. Take a full 15. After the break, we'll do 3-6. We'll do one problem from 3-6.